Now we're going to start looking at harder examples of arithmetic series. So the kind of rule, the golden rule we're going to use for arithmetic series is this one here in the red box. So it's the same thing, just written in two different ways. So depending on your textbook, it's the same rule. So I'll go through it anyway. So t of n is equal to s of n minus s of n minus 1, or t of n is equal to s of n plus 1 minus s of n. So the best way of explaining this is kind of by writing it out. So generally use this if we want to find t of n, if we want to find a certain term, or if we want to find the general term. So for example, if we want to find a certain term, if we want to find t of 5, yeah, and we know s of 5 and s of 4. So if we know that, I'll say s of 5 is equal to 1 plus 2 plus 3 plus 4 plus 5, okay, and we want to find the fifth term in this. So just by looking at it, because it's a small one, you can tell it's probably going to be, so this is the first one, the second one, the third one, the fourth one, and the fifth one. You can tell it's going to be 5, and that is the answer. But just, I'm doing this as a basic example, but if they wanted us to find t of 100, we wouldn't be able to do this, it would be too hard, okay? And then s of 4 is the next one. So the reason I'm picking s of 4 is because you need to pick s of n. So again, we want t of n, so we want t of 5. So we need to know s of n, which is s of 5, and we also need to find s of n minus 1, so the series of one number lower than 5, which is going to be 4. Does that make sense? Then anyway, s of 4 is going to be 1 plus 2 plus 3 plus 4. So we can see if we want to find t of 5, okay, and this formula here tells us s of n minus s of n minus 1. If we were to minus these from each other, see that? So this is s of 4, this is s of so this is s of 5, this is s of 4. The answer would just be 5, because all of these are going to cancel, and we're going to be left with 5. So we're going to get that t of 5 is equal to, that looks like a 6, but it's supposed to be a 5. T of 5 is equal to 5. Does that make sense? And the way I'm saying it, just that, so if you want to get a specific number or a specific term, and all you have are the series, then you can use this rule here to find that specific number or term. So we're going to look at it in an example where we're going to look at the general case. So I'll show you what I mean anyway. So it's a really useful rule. I just have to know that all the time. Yeah, I'm just going to scroll back. Keeps doing this these days. And I'll give the example right here. So here's our example here I just scribbled out. So we have an arithmetic series, and it's given by the formula s of n is equal to 4n squared minus 3n. And it says we want to find tn and we want to find t of 100. So you might think that doesn't look much like the formula we've seen before. So the formula we've seen is s of n is equal to n over 2 multiplied by 2a plus n minus 1 by d. Yeah? If you multiply this out, you're going to get something like that. So that's what they did. They had numbers for n, a, and d, and they they multiplied it out, and this is the answer they got. Does that make sense? So if it doesn't look similar to that, if you want to multiply it out, you could find that it's that. So anyway, that's just a different way of writing, say, the series. And we're going to find t of n, we're going to find t of 100. So to find t of n, we're going to use the rule we were just talking about earlier in the video. So t of n is equal to s of n minus s of n minus 1. So I'm going to start by writing that down here. I'm going to say t of n is equal to s of n minus s of n minus 1. So we already know what s of n is. It's this one here. But what's s minus s of n minus 1? So that might seem a little bit of a weird question to ask, but if we want to write s of n minus 1, it's going to be it's going to be 4 multiplied by n minus 1 squared. So anytime we saw n, we're going to put n minus 1 in, and minus 3 multiplied by n minus 1. Yeah? So if we want to go through this, it's going to be 4 by n squared minus 2n plus 1 minus 3n plus 3. So minus 3 by minus 1 is going to be plus 3. And so our final answer is 4n squared minus 8n plus 4 minus 3n plus 3. It's going to be 4n squared minus 11n plus 7. That's s of n minus 1. So if we want to stick both of those into this term here, into this equation here, we can find out what t of n is. Yeah. So I'll go green. I'm going to say that t of n is equal to 4n squared minus 3 of n minus this thing here. So 4n squared minus 11n plus 7. So that means that t of n is going to be So 4n squared minus 3 of n is going to be minus 4n squared plus 11, because minus and minus, and then minus 7. T of n is equal to the 4n squared, and the 4n squared will cancel because it's minus and it's plus and minus. So 11n minus 3n is going to be 8n, and then minus 7 is this here. So now we have t of n, and we can find any individual term in this series. So sometimes, like, the series there is only useful if we want to find the sum of, say, like for example this one here for all of these numbers. But what, for example, if we want to find an individual one, then the series isn't much good, and we need to know what the formula is for the sequence. Okay, so hope that made sense. We're going to try then find t of 100. It's going to be handy enough once we have our general form for t of n. So it's just going to be t of 100. Ooh. Oh, what's happening with this thing? So t of 100. Sorry about that, it was acting up a little bit. T of 100 is equal to 8 multiplied by 100 minus 7, which is going to be, again, it's just 800 minus 7, which is going to be 793. So hopefully that all made sense. Just trying to explain why exactly that is, that t of n is equal to s of n minus 1, which I did here. And then as well where that could be useful. So for example in a question like this where there's no numbers, you just have to do it with n, and then you can find any t you like. So again, hopefully that made sense. We're going to look at more examples of arithmetic series in the next video, so we'll see you then.